So, the goal of any scientific method is to solve a problem or to better understand something. Right now, as a world, we have coronavirus. It's huge. It affected your life and mine. In 15 or 20 years, when oil are beginning to be more scarce, how can we access oil deeper in the ground, or how can we recycle it? That's a problem. As people get older, and living longer, what is one way we can prevent Alzheimer? I don't know about you, but I really fear that to be able to live every single day and forget everything you learned that day. You have no new memory, so you don't remember what your new grandkids will look like, or you don't remember if you eat lunch or not, and you have to like feel your stomach to figure out if you had lunch or not. So that's something to deal with. So any scientific method is simply to solve a problem or to better understand something. What is an observation? Observation is just being aware of things. It's just a scientific word. The most famous character in a a fictional story is Sherlock Holmes. He's famous because he's able to notice detail. Detail is what helps him solve cases. Detail is what is able to help him get away from the mastermind, the evil guy in that story, okay? So observation is just being aware of things. People who live without being aware of their environment or other people around them don't really have a rich, full life experience as much. Because why? You just being dazed, and being dazed is not as meaningful as being aware. So observation just means being aware. You can observe things through your senses, or sometimes you can use tools like microscope, telescope, magnifying glass, computer program, video camera to make observation. Okay? So sorry, I went pretty fast there. And last but not least, I'll note end with this, and this is the most important thing for today: a hypothesis. A hypothesis sounds really, really like scientifically complicated, but what is it? It's just a good guess or a good prediction. Like it's sunny outside. You guys can see me. The window is facing in today. It doesn't look like it's blowing outside, so I'm guessing I make a hypothesis that it's a good day to go fishing today. I'll feel comfortable outside. So if the weather look like it's nice and there's no wind, then fishing will be comfortable. So any hypothesis simply is an if something happened, then there's a consequences. And you guys know, like what goes up must come down. The action is you throw a ball up, then the ball must fall down because of gravity. So hypothesis is just a really good prediction, but it's a prediction that's based on something. It's not just like random guess. Okay. So as I was going fishing a few days ago, I made an observation for you guys. After our last synchronous meeting, I took a little break and I went fishing. Please, in your notebook, write down a couple things you are able to. Not no, I'm sorry, not in your notebook. In your scratch paper, what are a few things you notice in this picture? If you are a fisher person and you're trying to catch fish, so take about 20 seconds or 30 seconds. What do you notice in this picture? Jot that down, and I'm gonna call on a few of you to tell me what do you notice. Just a couple facts. Okay. Anyone want to volunteer to tell me one thing they noticed in that picture? Just unmute your microphone and please speak. Let me go back to the picture if you need. Go ahead and speak. No one's going to see you speak because we're on this slide. So go ahead. Anyone?
The blue arrow wasn't pointing at all the minnows. It was pointing in the different direction.
Very good. Okay. So maybe that's indicating the direction of the wind or the way the current flow, right? Very good. Blue represent water. So very, very good. Anyone else? Any other observation? Don't be shy. To learn to be aware of things makes you better at solving problems. Anyone else? Please practice participating and speaking up. No one's seeing you right now, they're just hearing your voice. Okay, I guess I have to call on people. I don't want to do this, but you guys made me to. Okay, so let's go with alphabetical order, just from the top. Let's go with Lofton, Mr. Lofton. Anything else you notice, Mr. Lofton? Please unmute and speak.
I noticed those small, tiny animals, like tadpoles.
Okay, so small minnow or some smaller prey. Very good. Okay, so we'll have more time for you to notice that, but right now let's continue. So that was what I noticed. I noticed the minnows, aka baby fish, are coming into shore. That means that the bigger fish that eats them will probably gonna come into shore too. I also noticed that the water by shore is somewhat clear and the water out is a little bit murkier. You guys see the water out here is a little bit less clear. But that means that the predator fish is still able to see the prey very well, right? You know, fish that can see 3 times or 4 times better than us in water. So based on that observation, what question can I ask? The question that I can ask is maybe what bait should I use? How should I use my bait? Should I have a bait that sinks deep or should I have a bait that sinks shallow? So from this, if you guys were to make a hypothesis, what should you say about the bait? You want me to use something that sinks deep and drop down deep, or you want a bait that runs kind of shallow, not very deep?
I'd guess that since it's shallow, then you should use shallower bait.
Okay. Next, you want me to use a very bright color bait like orange or bright yellow, or you want me to use something that's kind of grayish, blackish, or greenish that looks natural based on the water clarity? Feel free to speak up. This is all class, not my class. Bait that looks bright or bait that looks kind of natural? Go ahead, folks.
A natural colored bait,
Okay.
not a bright colored one.
So from that, I'm going to make a hypothesis, right? An if-then statement. If I use a bait that looks kind of natural, long and skinny, and because the water is clear, right, then I will be able to catch a predator fish. Or another statement is, if I move my bait from this direction, following the current of the water, it'll make it easier for the predator to chase because they're flowing with the stream. So a hypothesis is, if I use a bait similar to the bait fish and throw them in the same area, then I can catch a fish. Does that make sense, guys or girls? Everyone, thumbs up for me, if that makes sense?
Yeah, makes sense.
Right? So you see, I'm using science for my hobby. I use science for photography, for video game too, and so on. But I need the rest of you to start thinking and practicing because you guys use this every single day in your life. So if I use a bait similar to it, I will be able to catch a lot of predator potentially, okay? Now, a hypothesis can be wrong, can be partially wrong, or it can be correct, okay? So once again, the presentation is on the right. So let's see if Mr. Vu is correct. So I threw it in the same direction as the water. As you guys can see, my bait, it looks kind of like the skinny fish, and I was able to catch a walleye about 2 minutes later. I used a very light hook, a very light jig, so it doesn't sink deep, and it worked. So my hypothesis in this case was proven to be correct. Next, after I threw that bait for a little bit, I noticed I wasn't catching any more fish. So I made another hypothesis. If I switch bait, maybe a different fish would react and bite. So I did switch bait. And hopefully, let's see if we can get this to work, because I have a screen recording program on top of this. So I switched to a different bait that was a little bit noisier, and I was able to catch a bass. So let me replay that for you guys because it's only about 15 seconds. And just to prove it to you guys that it is the same spot, you can see all those minnows swimming around in the water right there. So my hypothesis of throwing a bait in the same area as the minnow allow me to make it possible. So I'm going to pause our recording here because from now on it's you guys discussing. We don't need to record it. Anyone who missed the class would have been caught up with that 8.5, 9-minute video.